Okay, so this video is for day 6 and 7, part A, question 11. So we have A and B being 2 points on a plane, and O is the origin. Prove that vector AB is equal to vector OB minus OA. So the first thing that I'm going to do, because these vectors are tail to tail, I don't really like that. When I'm adding vectors, I want them to be head to tail unless I'm going to use the parallelogram law. So I'm basically just going to redraw, and it's not going to be very accurate. I'm not measuring it out or anything, but I'm going to redraw these. So this would be vector OB, just shifted up. And then I'm going to redraw OA. I'll redraw it in blue. So hopefully that you could see that I've just shifted OA to the right, and then I've shifted OB up. So if I'm trying to find vector AB, so starting at A, ending at B, what I need to do, and I'll just use a highlighter here, I need to start at A and go this way plus this way. So what that is vector OB plus vector AO. Now this question says that I need to prove, that's vector AB by the way, that I need to prove that vector AB is equal to OB minus OA. So I'm pretty close. I've got OB, but this one says plus AO and this one says minus OA. Now we know that if I have vector AO, it is the exact same as a negative OA. It's just the exact opposite vector. So really, this is the exact same thing. So I'm just going to erase this line here. And I am able to say that vector AB is OB plus negative OA, which is, and you don't need to write this second line if you don't want, OB minus OA.